Good morning, everyone. It's good to see you all this morning, looking quite lovely. Thank you all for being here once again. This morning, we will be doing another unit relating to climate change. We'll be doing the topic sea level rise. We're going to be talking about water, quite a whole lot today. And so, before we begin the lesson, we're going to go outside and we're going to set some things in place to do an observation later in the lesson. Okay? So you have your books, you have the page, it's page 65. You will follow those instructions and just be assured that I'll be right there to guide you as you go along, and you'll be trying to do exactly what it says in those instructions. So I give you half of a minute to read over the instructions for me, please. Would anyone like to read the instructions? Can someone read? Erwin?
You will need a large metal or plastic bowl, a pitcher or a bucket, a sheet of clear plastic wrap, a dry ceramic mug, a long piece of string or rubber band, and water. Directions: put the bowl in a sunny place outside. Using the pitcher or bucket, pour water into the bowl until it's 1/4 full. Place the mug in the center of the bowl. Be careful not to splash any water into it. Cover the top of the bowl tightly with the plastic wrap. Tie the string around the bowl to hold the plastic wrap in place. Watch the bowl to see what happens.
Thank you very much. So when you go outside, you will be getting a bowl. What else will you have there? You'll have your plastic wrap. You will have rubber band. You may need to join rubber band to fit around the bowl. We have enough out there to use. You will need your cup, and you're going to place the cup within the bowl. I'll be right there with you all to see that it all happens. How much water should you put in the bowl? Can we make sure? How much? Quarter. So we'll have the bowl about a quarter, not more than that. And then we will be able to cover that all up without splashing any water inside the cup. The cup will remain dry inside, and then we will see what happens later, okay, to answer some questions that we have there. So, are you ready? Let's go outside and do something then, okay? Okay, students, you are in your groups, and you have some items in front of you. We will be observing today what happens with these items. We're doing an experiment on the water cycle. Now, I'll ask you to please follow the instructions. You will need a quarter of your bowl filled. You will need to keep your cups dry. You will need to cover it tightly and to make sure that your rubber band is all around your bowl. So I ask you to work together, be as accurate as possible, and we will be, later on this morning, we'll be coming back out to see exactly what happens. And we're having some very nice sunshine and heat at this time, so our observation should be a very good one. Okay, so I ask you now to get in your groups, work together, and let's see you do your experiment. You can begin. Thank you. So now your water is in there. Your job will be to make sure that it's covered tightly with the rubber band and the plastic. If you need more plastic, I have some right here. Good group work. I like how you're working together. Very good. Some people making sure that the cup is directly centered. Very good. There's more plastic here. You need more more? Do you need more? Call on me for more plastic if you need. Make sure that it's tight. And I'd like you to remember where your group was standing and where you set it. Remember that plastic can stretch a bit too. Very good. Good group work. Teamwork going on. It's very nice. You might want another piece there. You want to stretch it so that it's tight and no air passing through it. You want this piece here? You like to set another piece on it? I don't know if you want. Very nice. Good teamwork. Now stretch out the plastic. Make sure it doesn't tear, but make sure that it's tight enough. All around. All around tight enough. These girls are doing a good job here too. Stretch out plastic, you don't want any air to pass through. All right, give me a clue when you're finished by standing up. And then I'll ask you to please take in the water, the mug with the water that we have there. Stretch it, honey, stretch it. See, you're stretching it, it's working. If that one is... There are some girls there who want to make sure that there's enough heat passing through that plastic. Thank you very much. Really like to see how you work in your team. And then we'll see when we come back outside what really happened and if you did well putting your items together and seeing how the experiment, what happens in this experiment. Thank you, students. Can we go back inside now? There are many people in many countries who do not have the tropical weather that we do, and they experience a lot of heat and a lot of dry weather. And so they long for rain. The water cycle doesn't occur as much as we experience it. But we need the water cycle. And it is sometimes, I believe, it's messages to us to make us realize that what seems to be natural is given to us, and it's us to make sure that we take good care of it so that it will always continue to occur so that we can live and benefit. The earth have limited amount of water, and if water that evaporate never return to earth, we would not be living now. We can live without food. Do you know we can live without food a longer time than a week? And for water, we cannot live without water. How many of you can go one day without water, like without a glass of water? Have you ever done that? Have you ever done that? Have you ever gone one day, 24 hours without water? Whether it's in juice, whether it's plain water, or whether it's drinking a snow cones, we do get some into our bodies, isn't that so? Or a cup of tea or some milk, we do get some of that liquid, and it all contains water. The water cycle is called the hydrologic cycle. It is the circulation of the earth's water. So this cycle, when you hear about a cycle, you're talking about a circulation, a continuous process. There's no end to it. There's one step and another step and another process and another process, and it continues. It never stops. Water evaporates from the sea into the atmosphere, where it falls as rain or snow. And I want to challenge you on that. It says water evaporates from the sea into the atmosphere. Is that a true statement? Alexander, do you agree with that?
Yes, ma'am.
Why?
Evaporation process.
Because
the
of the
water cycle.
Because of the water cycle. All right? Yes, we know that water evaporates from everywhere there's a body of water. But when we have all the water that runs, eventually, for example, where does a river lead to? The sea. And so all bodies of water eventually leads to the sea. They connect at some point, and then it leads to the sea. So it is a true statement. Okay? It encompasses all of the different bodies of water because it all leads to the sea. Water returns to the atmosphere through evaporation or transpiration. Can anybody explain transpiration? It came up before. Do you remember? Anyone remembers? Erwin?
I think it is when water is taken from a plant or a living thing, like you can see it sucked right out of it and go into the sky.
Yes, that's true. All right? Transpiration relates to the plants. It's how the water that evaporates from the plants. Which main part of the plant does that happen from? The leaves, correct, the leaves. Okay, I have some key terms here that will help us to understand the water cycle a little better. Evaporation, we mentioned that word before. Water molecules from lakes, rivers, streams, reservoirs, and the ocean get heated by the sun and turn into vapor that rises into the air. So it's the water that is in all these places. And that water eventually, and it continues to rise as a gas, the vapor, and later that goes up into our atmosphere. So that process is called evaporation. Transpiration, as shared by Erwin, it says plants are heated by the sun and send water molecules into the air through their leaves. Quite correct, Yadira. Condensation. And what is the process of condensation? The process in which water vapor in the air turns into liquid water, which form clouds in the sky. So when that water vapor goes up, it forms droplets of water, and those eventually forms the clouds. Water drops that form on the outside of a glass of icy water are condensed water. So whenever you hold a glass with water and ice, and that ice is melting, and you see all the droplets outside of out of that glass, that is actually condensation. And we will be seeing some of that in our experiment when we go back outside to observe. Precipitation. This occurs when so much water has condensed, all of it, that the air cannot hold it anymore. All these little droplets come together now, and the clouds get bigger and heavier. Eventually, it is too heavy, and so it breaks, and that causes the rain. The clouds get so heavy, and water falls back to the earth in the form of rain. It comes down as hail, it comes down as sleet or snow. Which one do we experience mostly in Belize? Rain. Is there any other? Do we experience snow? No. Not yet. Not yet, and we hope that we don't have to, right? There's another one that happens sometimes in the Cayo district. Erwin,
It's hail.
Hail. What is hail?
Hail is commonly seen in the Kaya district, and it's chunks of ice falling from the sky.
Yes. There was also, about 2 years ago, there was hail falling in Corozal district also. So from time to time, we do get precipitation of hail in Belize. Can you continue? Accumulation. We need to understand accumulation. Can I ask Glendy to read what accumulation says?
Is the process in which water pools in large bodies like oceans, seas, and lakes.
Yes. Where you have that large body of water, that is accumulation. All of it accumulating together. So the ocean and the seas and the lakes, those are accumulation. Surface runoff. Can I have a volunteer for surface runoff? Okay, Edwin?
Surface runoff is rain, snowmelt, or other water that flows in surface streams, rivers, or canals.
Okay, thank you, Edwin. It is rain or the snow or other water that flows in surface streams, rivers, or canals. And the other one is subsurface runoff. Subsurface runoff. When we use the prefix sub, do you know what sub means? Tell us then, Edwin.
Sub would refer to something underground, like
Yes, under, it's lower.
under something.
Thank you. Subsurface runoff is the rain, snow melt, or other water that flows in underground streams, drains, or sewers. So which one would come first, the surface runoff or the subsurface runoff? Which one would come first? The surface. We'd have the surface more to the top, and then we'd have the subsurface under. Isn't that so? Underneath. All right, I have a little activity for you now. If you turn to page 63, there's an activity there. You will find a picture very similar to this one. Do you see that? It's on page 62, am I correct? Okay, you'll find a diagram very similar to this one. You will not find the X's. Is that so? Okay, and you will not find the little trees. Do my trees look like trees? Okay, now you need to draw some trees. Kindly put some trees in that diagram. Yours can be prettier than mine. Yes, put some trees on the diagram. Okay, now that you have your trees, I want you to check the diagram in front of you, the sample I gave, and I would like you to look at where I have placed those red X. They're the same terms that I explained just now that we discussed just now. Those same terms are there. And I would like you now to pair up, or since you're in groups of trees, discuss the diagram and try to place those terms: accumulation, precipitation, evaporation, surface runoff, subsurface runoff. Which one did I miss? Transpiration, condensation. Place them in your diagram. Kindly place them in your diagram. You can discuss before you do. So since you are in trees, you can work in trees, and you can discuss and place them in your diagram. Remember to discuss. I gave each group 1 or 2 flashcards. It has the same term, the same word you're placing in a missing, on a missing line in the diagram. Those are the same words. And I will ask you to choose one of the 3 of you to represent your group. And now I challenge you, which I know is a very easy one, I challenge you to go and place it on this bigger diagram. So when you're ready, feel free to come and place your word on the diagram in front. Talk to your peers first before you come. And it's okay if we don't get them quite right, because we're in a learning process and we're doing processes. So it's okay if we don't get them right, then we'll all correct each other. We'll all get it right together. When your member comes and places the card, someone else can explain in their own words what they understand the term to mean. You ready? Come then. You can take your tape from there and you can place your word. Glendy is ready. Could you put 2 on so they don't drop? They're kind of long, 1 on each end. Kindly put 2 pieces of tape on each end so that they don't fall. Remember, I asked you to use the red X. Thank you, Glendy. Anybody else ready? Come on down. A little more down. Thank you. Go on up. If you have another one on your desk, please go up. Could you say the word that you're placing there? Surface runoff. Next, we have subsurface now. Any more to be placed up here? Okay, can maybe Krisha, can you come and do that one? Okay, thank you. 7 terms. Do you agree with all? No, you don't? Okay. All right, we have precipitation. Do you agree with precipitation?
Yes.
Condensation?
Yes.
Okay. Surface runoff?
Yes.
All those who agree, raise your hand. Okay. Evaporation? Thank you. Accumulation? Thank you. Transpiration?
No.
Okay, how many of you don't agree? All right. So which one do we want to shift? It's going to be shifted with subsurface. Let's go back. What did we say the prefix sub would mean? Under. Okay? So, Evelyn, remember now, the other time that, and thank you for coming up and representing your group. Okay? For sub, what will help us to remember this is that this means under, so it would go under. This one is surface, right on top, and the sub would go more below. Can you come and do it over, please? Come and correct it. And that's how we reinforce and that's how we remember, okay? And it's okay for us to try and make a little error. That happens to everyone. So let's change this to a wrong. Transpiration, we remember, what's the key word to remember transpiration? The key word to remember the meaning of transpiration, what this process is. Plants. Come on, Evelyn. Help us with transpiration now. Come on. We keep calling on you, but that's because you're a kind girl. Thank you. Thank you very much. Give yourselves a hand, please. Now, my challenge is to explain in your own words now. Very simple as you can. I see people looking down now. They don't want, let me see. Rosalina, transpiration in your own words. What do you understand transpiration? What's the process of transpiration? In your own words. You can call on a group member to help you. You can call on your group member to answer the question for you. Transpiration. And while this group thinks about transpiration, Edwin's group can think about condensation. Okay? Can I get your permission to put this condensation more in the middle? Thank you. And we'll talk why. Okay? No, it wasn't wrong. It wasn't incorrect. Okay? We'll say why, and you will explain why. So let's hear about transpiration then. This is how we will remember. Kyle, they have called on you, Kyle.
It is when the sun heats the plant, and then the plant lets out water through its pores, and then it goes into.
Very well said. The sun heats the plant, it lets out water through the leaves, through the pores on the leaves. Very good. Good representations, Kyle. Edwin, who will represent your group? Edwin will. Go ahead.
Condensation is the process in which hot air, which is the water vapor, rises and meets the cold air. It then cools down and forms water droplets and gather together to form clouds.
Thank you,
in
Edwin. Now, you gave me permission to put it in the middle. What did you say happens to the clouds? They gather. Do you understand why? All right, good. So this was not incorrect. But it's also clouds that will eventually, but the gathering, the diagram is trying to show the gathering. Okay? Thank you. Is there anyone else who would like to explain surface runoff? Yadira wants to take it up. Go ahead.
Water that flows to rivers, streams, or water bodies.
Yes, the water on the surface of the earth that flows to the rivers and other streams. Okay? Very good. Subsurface runoff. Can we go to, would you want, Evelyn, would you like to get a member to answer? You go right ahead and call on one of them. Irma is waiting. Right, Irma? That's a good student. Go ahead.
Subsurface runoff is when water flows underground.
Water flows underground. Thank you very much. That's a key word there. Let's do one last one. Evaporation. And that will be for Erwin's group. He can call on another member if he wishes to.
Evaporation is where water droplets turn into vapor and goes up into the air.
Okay, water turns into vapor and goes up into the air. Thank you very much. Right? Now, earlier I asked if you remembered some information on water cycle. And most of you said it wasn't really coming to you. Do you think that this activity will help you to understand the processes? These are the main processes, all right? This is what actually happens, all right? So here we have completed this. Now you can check to see if your terms are in the right place. Kindly check to see if your answers are right. And later you can give yourselves a score. Okay? Okay, let's continue then. Groundwater, the term that was used when we discussed subsurface runoff. There's a diagram in front of us. There's a diagram in front of us showing, actually it's the water cycle. It shows a little bit more than these 7 terms that were discussed. There's condensation, there's evapotranspiration, with meaning it's evaporation and transpiration. Later you will be hearing in your next lesson about unsaturated zones and saturated zones in the earth. You'll be hearing about the recharge, and right now our interest is the groundwater. Where do you see groundwater? As its name says, Stephen?
Ground and wells.
Ground and wells. Thank you. Have you ever seen a well? How many of you have seen a well? A shallow well? A deep well? Okay, all right. Thank you. Groundwater. It is the water that is found underground in the cracks and spaces in soil, sand, and rock. How does that water taste? Would we consider it salty or fresh? It is fresh. Good. Again, Edwin?
It depends on where the water from the subwater came from. Like if it was water underground at sea, then probably depending on how much it was filtered by the soil, not all the salt could have been removed from the water.
Okay, I like your statement. We'll check it out later, all right? Groundwater is stored in and moves slowly through layers of soil, sand, rocks called aquifers. Aquifers are typically consist of gravel, the sandstone, or fractured rocks like limestone. Actually, what are we talking about? What are those things that makes up the aquifers? What are those? Where is it? Under the ground. Okay. Gravel. Have we ever seen that? Yes. Sand. Yes. The sandstone. Yes. Limestone. Yes. Have you ever seen water seeping through? Yes. For example, when a road is broken, yes, sometimes you actually see that water trickling across. Okay. Infiltration, that's another key term that you all will be discussing, is when rain or irrigation water is supplied to a field, it seeps into the soil. Right? Let's look at another picture that we have here. Take a good look. There we are. The water cycle. Notice here is the groundwater. What are these representing? Those who are closer can see. The wells. So, actually, what are the wells used for? To bring water to the surface, right? Here is surface water. Here is the groundwater. What do you think these brown areas are representing? I'm hearing it. I'm hearing it. Let's hear it. Raise your hand and give it to me. I'm hearing it. Aquifers, yes. All the sand and the stones and all little pebbles that are underneath and the water is flowing through. All right? You can take another look at it later. What is groundwater? First and foremost, it is water. It is water that is out of sight and below land. Below land surfaces, it is almost always unseen. Yet we depend on it so much. Groundwater moves slowly through small openings or in between sand grains of subsurface materials. Subsurface materials, the aquifers. Materials that provide storage for groundwater are called aquifers. Groundwater always move away from high pressure towards low pressure, down gradient. The gradient means the slopes, all right? They usually move from high to low, as it says. So they move down slopes. Here we saw a slope. This was like a slope, and then we had the surface, and then we have the subsurface underneath. There are lots of slopes. Isn't that so? The land has a lot of slopes. Gradients exist naturally because groundwater enters the water cycle at high elevations and eventually flows towards the ocean. And that's the reason why I said it in the beginning there, that when it says that the water flows to the sea, it's the sea water that goes up. It's a true statement because all these streams, the rivers, everything connects, and eventually it's to the sea, and that evaporates, right? So even the groundwater that enters the ground, eventually it leads to the ocean. Natural gradients can be altered by withdrawing groundwater from aquifers using wells. As someone said, the groundwater comes from wells. It's the wells that are used to withdraw that water. We see the source of groundwater when it rains. Actually, all that water that goes on the surface, all doesn't go up and evaporate up there. A small portion of that rain will stay on the ground, and it's going to infiltrate, right? It doesn't evaporate. It goes into the soil, and it goes deep, very deep in the geologic formation. It's called what is called a water budget. Actually, it's just that it's under there, and there's a whole process that happens down there, right? It's all collected. Groundwater moves at modest fractions of about a foot per day. So when it rains, it's not that it's just going to soak up and go down there. It moves very slowly. It goes down very slowly, right? Groundwater discharges to surface water bodies. So eventually it goes back to the surface. Groundwater is usually withdrawn by wells, like what was said before. Now, here's a picture of Belize. This is a picture from Belize, and it's actually groundwater. Is it far below? Why do you think groundwater is here? The water may look like that, but what type of water do you think you're getting in there? Fresh water. If it's groundwater, it's fresh water. Okay? What would have occurred here that now makes this hole filled with groundwater? Where would we see these a lot? Or what would happen to make these occur? Edwin, use the mic, please.
The carving of limestone from water or rain.
Okay, could you explain that a little bit more?
When it rains on streams or water would run off into caves or different sections, and for years they would carve out some holes.
Okay, carving out of
caves.
holes. Okay.
And then water accumulates.
Okay, very good, right? There's also an activity that happens sometimes. In the village where I live, it happens a lot. We look around and we see these, and we call them ponds sometimes, and people actually go and they like to bathe in them because it's fresh water. It's actually groundwater. A lot of this happens when the earth is taken out to be used. The sun is collected, the earth is dug, and eventually what will happen there, the groundwater will seep up, will come up, and then that water is fresh. And many times, as I say, people call these ponds, and they would use them for household purposes, to serve their house with water to use to bathe or to wash, things like that. When there's a shortage of water, and I know of actually people going in and bathing in them because it's cool, fresh water. So that's a picture actually from Belize that we're seeing the groundwater not very far below. But if you notice, it is in a hole. Somewhere along the line that was dug out, whether it's from erosion or it was dug out for sand purposes, for fulfilling somewhere else, but that's a groundwater. That's the hole with groundwater. Okay, can we continue? What is groundwater again to wrap up here? Groundwater is water located beneath the earth's surface in soil, pore spaces, for example, like what we saw just now, pore spaces and in fractures of rock formation. So where, as you said, where the rock starts to break away, Edwin, you have the carving out. You said sometimes even in the caves or so, where you have those rocks, the fractures of those rocks, you're going to get groundwater taking those areas. Groundwater is recharged from rain. So whenever it rains, some of that goes down, and we are able to use that. And eventually flows to the surface naturally. Natural discharge often occurs at springs and seeps. Have you ever come across a spring? Have you ever come across a spring? Would you like to explain what that is?
One time I was by a river and I noticed there were some holes in the ground.
Yes.
And there were water in it. It was a bit close to the river, but then I got curious and I started digging out the dirt.
You got curious. That's
and
good.
I see water start coming out, but I don't know where it's coming from, and it's uphill, so I don't know.
Okay.
I didn't think it was coming from the river, so I started digging and water continued flowing out,
Okay.
and then it started running off into the river.
Actually, those people who are doing purifying of water, who are selling the purified water, they're making use of springs in Belize. Okay? They're making use of springs in Belize. I had the experience of being on a farm, and they were actually digging out a whole area for a fish farm. They were going to put some they were going to do some tilapia farming. And I remember when that excavator just continued to dig, and it had to go very deep. And then everybody got excited. They said, we meet the spring. We have the spring here. And one of the men went down in like a bucket, and he came out with a cup of water, fresh water. Everybody wanted the taste of that first water that came up in the cup. And eventually, that water just continued to seep and seep out, and then the hole got all filled up just like the one that you saw. I had actually had the experience of being there when it was done and tasting the water too, because it's fresh. So it's recharged every time by the rain. Natural discharge often occurs at springs and seeps and can form oases or wetlands. So sometimes it actually causes wetlands. Some lands just continued with water. Groundwater is also often withdrawn for agricultural, municipal, and industrial use. A lot of times, those are what the wells are needed for. Municipal, meaning in busy areas, for example, for businesses, for people's home, in cities, wherever, we are getting that groundwater. In Belize, we are getting groundwater too. Industrial purposes, for factories, some of them do get their water that way, most of them. Industrial use by construction and operation extraction wells. Right? The study of the distribution and movement of groundwater is hydrogeology, also called groundwater hydrology. So when you hear about hydrology, we're talking about the study of groundwater. And we do have people at the Met Office that their first responsibility is to continue to study the groundwater in Belize, because they have to report on what is occurring with groundwater in Belize. Right? The importance of groundwater. Would you like to take a guess of why groundwater is important? Why we need to discuss groundwater? Go ahead, Edwin. Why is groundwater important?
Groundwater is very important for plants, because some of their roots go really deep underground looking for water. Sometimes they can't find close to the surface, so their roots grow farther away where they can find water.
Okay. And when that water is penetrating through the aquifers, then it gives that service. Good. Erwin?
water sometimes, well, plants, they need water, and then if they're far away from streams and water bodies, they tend to try to find water underneath the ground, and that's where the
And what's the
groundwater
term
comes
that
in.
farmers use for that, especially for farmers with their plants? What do?
They use wells.
They use wells. They do irrigation, right? And infiltration of the water. All right. What about us? Don't we need the groundwater? Do we drink groundwater? Yes or no? Yes. Okay. Thank you. Okay. Many commercial businesses and industries also depend on groundwater for their process and operations, right? Many industries rely on clean groundwater for the production of electric power, food, beverages, and material production. Groundwater is a vital source for fresh water in rural Belize. This is specifically about Belize, where almost 95% of the fresh water supply comes from groundwater through the Rural Water Unit, the Ministry of Rural Development. Groundwater is extracted in rural areas through the use of hand pumps and rudimentary water systems. Rudimentary water systems mean basic water systems. I remember when some years ago, about 30 years ago, living in Corozal, we used to collect all the water with a bucket and a rope. And every morning before I left home, I had to go and do my share of pulling up water. I have strong hands now. Okay? Right. So that's the rudimentary water system where you might not be able to afford one of these electrical pumpers, but it can also be done in basic ways, for example, in a hands-on way. Okay? Observation and experiment. So now we should be, in a little while, we'll be going back and looking at the experiment that you will do. Dave, why is groundwater important to the water cycle? Could you turn to your books? It's on page 62. And could you take a little time now to write some of what may have been mentioned or some of what you may want to include? Write your response in a very short paragraph. Why is groundwater important to the water cycle? And remember, consider us as a part of that, the importance of groundwater to us. It has its part to play in the water cycle. Normally, when we talk about the water cycle, we rarely mention groundwater. Today, we are finding out that it's important to consider groundwater in the water cycle also. When you're through, kindly sit up, and I will ask 2 volunteers to share their answer, their response that they gave. Okay, kindly sit up. Take a little look over what you wrote just now, and I'd like to see 2 volunteers. Okay, Carl has volunteered. Can I get volunteer number 2? Erwin. Okay, so they will now share what they wrote.
Groundwater is important because it is needed in our survival for drinking, health, and other purposes. Also, it is a major part of our water cycle. Groundwater also provides water for plants.
Water for plants. Let's hear from Erwin.
Groundwater is important since it's fresh water. Some groundwater turn into underground streams which eventually lead into rivers and seas and then evaporate and come back to the surface as rain, snow, hail, and so on, allowing us to survive.
These 2 young men did such a very good job. I believe they gave a whole summary of what we spoke about. if we were to leave here without relating the water cycle to the climatic change, we would not have completed our lesson the right way. These lessons, we all want to make sure that we understand the importance of all that is happening in nature. Today we talked about the water cycle and how it impacts us, because, for example, how much we need it and how in any way we affect the water cycle, or how we relate back to the water cycle, how we use it, or how we treat the water around us. Climate change is having an impact on water cycle. Do you agree with that statement? Climate change is having an impact on water cycle. What would you consider an example of climate change having an impact on water cycle? Go ahead.
Climate change, in the topic which deals with global warming, I would say more heat.
More heat.
Causes more evaporation.
More
More
evaporation.
clouds, which in return would cause more rain and more thunderstorms.
Okay? Yes, it does affect more heat, more water dried up too quickly. So how much time does it say that the underground, that it takes for the groundwater to reach Earth of travel? 1 foot per day. So wouldn't that have an impact on groundwater? Yes, it would. And it's the groundwater we actually need. Isn't that so? We need all of it. We need all of our marine sources and everything, but we use the groundwater mostly for our survival. Raising the issue of whether we should be investing in adapting to these impacts or focusing on more pressing water resource issues, such as providing water and sanitation for increased population. Continued increased population will mean more groundwater being used. Isn't that so? Isn't that so? All right? So it's calling our attention that while we have all these sources, we need to be careful, and we need to discuss these and what should be happening in our environment and with our people. Do we provide water for sanitation and for increased population? Yes, we need to. Yes, we need to. If investment in adapting to climate change is a priority, then is it best to invest in protecting natural ecosystems or developing engineered infrastructure? Now, let me see if you understand that. What is that saying? Let me read it again and you try to break it down. If investment in adapting to climate change is a priority, for example, this research station is an investment about teaching, researching how to adapt to climate change and how to make the difference with the difference of our behaviors. Then is it best to invest in protecting the natural ecosystems, or is it best to invest in developing engineered infrastructure? What would be an example of engineered infrastructure? More technology. Okay? More infrastructure around us, more things around us, more buildings. This causes for a debate. And so I would want 1 or 2 persons just to give their idea of what you think this is saying, or how would you respond to this. I'm not looking at Edwin. Look at what it aims. Just read it over for yourself. Is it best to invest in protecting natural ecosystems? Should we invest, like is what is happening right now? Or we're coming here, you're investing time to learn about climate change and what good we can do, what we can change, the mitigation and the adaptation. Is it good to invest in that? At the same time, we are investing in engineered infrastructure. Which one is more important? Which one is more important?
Investing in the protecting of natural ecosystems would be more better because by doing that you are helping the situation rather than trying to invest in engineering infrastructure which will just help you in adapting to it. It won't fix the problem, and after a while the problem will get worse, and then you're gonna have to invest more in other infrastructure. So
To
it's
fix
bet-
the problem.
yeah, so it's
Okay.
better to
It's
help.
better to invest in protecting. So what Belize is trying to do, what this research center is trying to do is very important. Should we invest any at all in developing more engineering infrastructure? Should we? Should we? More people being born, more water needed, should we? More water needed for buildings, should we? Invest? We shouldn't? So you have no room for your children then? No children. Because we can't do any more investment, no more. Is that so? Okay, I'm going to use a word begin with B and I want you to come up with it. What should we have a B? A balance. We need to learn how to adapt to balance it out because our future must continue. Isn't that so? Yes, we must continue. Right? Give yourselves a clap. Thank you. And I like your involvement. And thank you. They're still laughing. There's room for your children because 1.5, we will stay alive. All right? Okay, and that's why you're here. Thank you very much. Okay. Now, let's see if we're ready for outside. Let's check first because if not, we'll have to do it 12 o'clock again. If it's not, then we'll do it. If it's not finished out there, we'll give it a little longer time. Okay, they're still laughing. Thank you. I like when you're enjoying yourself.